We can also use our understanding of slope to determine whether a line is parallel or perpendicular. Now, parallel lines are lines that will never touch. They never meet. As you see here, you'll notice that no matter how far those lines go on into infinity, they will never touch. And that's what we call parallel lines. Now, parallel lines are parallel if their slopes are the same. If they're equal, we know that the lines are parallel. So as long as you can identify the slope of an equation of a line, then you can determine whether or not it's parallel. Now, perpendicular lines are lines that intersect each other but at 90-degree angles. We call them perpendicular. But in terms of their slopes are negative reciprocals of each other. And that's a key word. If you remember, the word reciprocal means to invert a fraction, to flip the fraction. So 1 over 3 would become 3 over 1. But not only that, you will also negate it. So if I had a third, then the negative reciprocal of that would be negative 3 over 1, or just negative 3. And if I had 2 thirds, then, or negative 2 thirds, my negative reciprocal would become 3 over 2. And if I have any relationship where the slopes are like that, then I can determine that it's a perpendicular intersection that is happening. All right, so let's see whether or not we can determine if these lines are parallel or perpendicular or neither. Remember, if a line crosses like this is neither perpendicular nor parallel because this is not a 90-degree angle. And so it can be neither. So let's go ahead and look to see what our representations we get here. All right, for part A, it says line 1 and line 2. We want to see if these two lines are parallel. So let's start by finding the slope of line 1. All right, so we find it, we could say M1 for line 1. So M1 would be equal to, well, let's just label these first. And so we have M2 is going to be negative 1 subtract Y1, which is 3, over X2, which is 3, subtract negative 3, which is X1. Now 1 subtract 3, sorry, negative 1 subtract 3 is going to give us negative 4. And 3 subtract negative 3, those two negatives in the middle will become a positive. So 3 plus 3 will give us 6. And that can be reduced down to negative 2 thirds by dividing each, the numerator and the denominator, by 2. All right, so let's see what we get for line 2 to determine which relationship this will be. So we call this one M2 for slope 2 for line 2. And we can use the labels from the first one since they're right above each other. So y2 would be 3 subtract y1 is negative 3, and then x2 is positive 2 subtract negative 2. And just the same, we have two negatives in the middle for each one, so that's really 3 plus 3, which is 6, and 2 plus 2, which is 4, and 6 over 4 reduces down to 3 over 2. Now, if you look at those slopes, they are negative reciprocals of each other. So these two lines are perpendicular to each other. And if we were to graph them, they would literally create a 90-degree angle if you were to measure them. All right, how about part B? I'll change the color for this one. And the same way, we're going to call it M1, M2. We'll label our coordinate points, Y1 here. Having some problem with the pen, and x2 and y2. All right, so let's go ahead and find m1. That's going to be y2 subtract y1, so 4 subtract 1 over x2, which is 3, subtract x1, which is negative 3. 4 subtract 1 is 3. The two negatives in the middle become a positive, so 3 plus 3 is 6. And this easily reduces down to 1/2. All right, let's try m2, the slope for line 2. And we'll use the labels again from the top. And so we have y2 is 1, subtract y1, which is negative 3, over 4, subtract negative 4. And once again, we have those two negatives. 1 plus 3 will give us 4, and 4 plus 4 will give us 8. And that will reduce down to 1/2 as well. And so these two lines would be parallel. Remember, if it was neither perpendicular nor parallel, we'd just say they're neither. This just means the lines do intersect, but not at a 90-degree angle. All right, so now let's just go ahead and see how we can use slope in real life. We normally call this rate of change, depending on the situation. An example of rate of change is miles per hour. That's rate of change and can be mapped on a graph as slope. So here we see average speed, exactly what we were referring to. And remember, speed to find your speed is distance over time, the distance you travel over the time. And so that can help you in determining your slope. Since distance is first, that's going to represent your y value. And since time is second, that's going to represent your x value. And we learned that before, that time always represents the x value. So all they want you to do here is to find the average speed. And because that's all they want, they basically want you to find the slope for this question. So it says you are driving through Europe at 9 o'clock a.m. You are 420 kilometers from Rome. At 3 p.m., you are 108 kilometers from Rome. Find your average speed. So we could start off with the beginning. If we were to put this in terms of time, we have this is our x1, that's our initial time, and then this would be x2. You could use t as well if you want to, t1 and t2. But because time is always on the x-axis, I'm just going to leave it here as x. And then our initial starting time distance, we could call that y1. That's what happens when we are at 9 o'clock a.m. And then our other one would be y2. So in order to find the average speed, we could just say our m, which represents average speed, is going to be equal to y2 subtract y1. So that's 108. That's not an 808. Subtract 420 divided by the difference in time. And that's going to be 3 p.m. And you could always write 3 p.m. in terms of the 2400 hours. That'll make the subtraction easier. Remember 12 o'clock, 13 o'clock is 1 o'clock, 14 o'clock is 2, 15 o'clock is 3. That's an option that you can do when you subtract it. It will make it a little bit easier depending on the times that you're using. So you could just say 15 o'clock subtract 9 o'clock. That will make it easier. All right, so 108 subtract 420. You could work that out. And that's going to be, I don't have a calculator, so let's see. 108 subtract 420. You could just say 420 subtract 8. That's another way to do it. And just make sure you have your negative sign. So that's going to be 312 divided by 15 subtract 9, which is going to give us 6. All right, so then we could just divide those two. Negative 312 divided by 6. And the answer to that is going to represent your miles per hour. Remember, the top row represents, kilometers. The top row represents kilometers, and the bottom one is representing the difference in hours. So your answer is going to be in kilometers per hour. I'm just going to use a calculator for this one. You could do long division on the side. Let's see, 312 divided by 6. It's going to give us a nice rounded number, 52. So that's going to be 52 kilometers per hour was the time that you spent traveling. Okay, so let's come over to the last one here, slope in real life. Still a concept of rate of change, but not in terms of speed. This one is referring to the pitch of a roof, and it says building codes require the minimum slope or pitch of a roof with asphalt shingles to be such that it rises at least 4 feet for every 12 feet. So first thing we want to do is kind of draw a house just so we can get an understanding of this. So the pitch of the house is just one of the sides. It doesn't have to be both sides because you just don't include that in the pitch. So, if you're just trying to walk on that, are you going to fall because it's too steep? Right? So it's talking about one side of that. And so the rise of the run is referring to, if I could change the color, it's saying that where is it to? That it rises 4 feet for every 12 feet of horizontal distance. So that means if it travels 12, then that part's 4. So it's like 12, 4, 12, 4, etc., right? So it's kind of making a step. We're just going 12 units over, 4 units up. 12 units over, 4 units up. So that's just one slant of it. So I'm just going to clear everything. So just keep that in mind now once we work this out. So first we want to find out what the slope is just generally using the 4 feet of rise. And remember, slope is rise over run. And so the rise of this is going to be 4 feet. And then the run, 12 feet every horizontal for run. We just have 4/12. And that's going to reduce down. They have common factors. We can divide both numerator and denominator by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So it has a basic pitch of about a third. For every foot, you go about 3 feet. So now we need to see for this 72 foot wide apartment building, and that has a 12-foot high roof. But we have to be a bit careful here because they're saying that the whole apartment building is 72 feet, right, from end to end. And imagine that includes the edges of the roof. I didn't sketch it out correctly. I put some roofs stop right at the edge, and so we're just going to assume that's what I done. But the key is that we don't want to get both sides of the roof, the pitch. We just want half of it, right? We just need this portion or the other side. They're both going to be equal. So if I'm having half of the house, I don't need the whole house. Half of that house is going to be 36 feet, right, or apartment, right? So that means for every 36 feet, and we're just chopping the roof off right here. For every 36 feet, it says we're going to go up 12 feet there, right? So 36 feet up 12 feet. So let's see if that meets the building code. The minimum slope has to be a third. And we want to see, do we get within the range? All right, so we're going to call this M is red. I could draw a house there. M house, right? So M is equal to rise over run. And what is our rise? Our rise is 12 feet, but our run is not 72, but 36. And so we could do the same thing. We can divide by 4, can go into both of these. 12 divided by 4 is 3, and 36 divided by 4 is 9. Oh, I could have went down even further. Uh, could have divided both by 12. Divide this one by 3 as well, and we get a third as well. So yeah, this just makes it right. It's actually the amount that is needed to satisfy that slope. So yes, it does meet the building code. Yes, it meets code. And you would normally write that a little bit longer. Yes, it does meet the building code because the slopes are the same, and because the slopes are the same, it meets the minimum expectation. Okay,